Bismillahirrahmanirrahim. Greetings. In the video lecture that I uploaded about a week ago, from the date of this video, I discussed about the analytical definition of a slope and the analytical equation of a line. Now, the contents of this lecture is a natural follow-up of that previous lecture, and for this reason I strongly encourage you to watch that lecture, that video, if you haven't done it already. Now, I have provided the site link of that in the comment section below, and and you can also search for it in my channel. Now, let's get started, shall we? Now, every line, regardless of its slope, will intersect with the horizontal line. Let's call it x-axis. Now, as a matter of fact, we can think about it as a analytical, because we don't need geometry to know what I said. This is exactly what analytical interpretation means. Now, since when two lines intersect, they form angles, so we are going to see, to stand back, stand by, look, observe, think, reflect, contemplate, and see if we can also have some analytical benefit from the angle that the line makes with the horizontal. That's exactly what we are going to do. Okay, now, since when two lines intersect, they form four angles, and mathematics is very meticulous and precise subject, so we have to be explicit which of the four we mean. And for this reason, I draw that one. This line and this horizontal line forms four angles, like you can see, and they are pairwise congruent. This is congruent to this, and this is congruent to this. Seeing is believing, you can see that, huh? Now, the angle that the line makes with the horizontal axis, with the x-axis, toward the positive direction of the x-axis, that is the angle of our interest. So from these four of them, we mean this angle, because this angle is what? Is closer to the positive x-axis, positive x direction. And also this angle, which is below, is also toward x direction. So in order not to get confused with that, we said the side that is toward the positive x direction, also above the x-axis, you can say. So these are the angles of our interest. Now I have another picture. I can give it to you so that to be kind of more explicit and comprehensible. Now, so if this is our line and this is the horizontal line, this is the angle of interest. And if this is our line, which has a negative slope, you know from the previous lecture, this is the angle of interest. Again, there are four of them. This is the angle of interest that we are going to concentrate and discuss. Okay, so far, so good. And now I'm going to, let me put this one up also, is just a little bit. Now this drawing that I made is a line and horizontal axis. This is not drawn in a scale. So I'm not using analytical geometry. So this is drawn as a visual aid to assist us to see if we can extract information that we are after, to see if any analytical benefit we can get out of this. This is our goal. So this, I wanted just to mention that I'm not using analytical geometry because I'm not drawing them in scale. Okay, from the previous lecture that I did encourage you to watch it, we come up with similarity of triangle. It was the similarity of triangle, that the observation of similarity of triangle, that motivated us to go to the analytical definition of a slope. Now we come up with analytical definition of a slope to be delta y over delta x. Now, but delta y over delta x, we know a little bit about what? About the trigonometry. This will be the tangent of this angle. So this over this is the tangent of theta in this case. So it looks like we have already come with some good idea. And the tangent, in other words, the tangent of theta is the same as a slope of the line. So we don't have to go to the delta y over delta x to get the slope of the line. We can, if we know the angle that the line makes with the horizontal axis, the tangent of that angle will be a slope of this line, a slope of the corresponding line. And seeing is believing, you can see that, huh? Ratio of this over this. Okay, now, by the way, let me say a few words about trigonometry in case if you may have, just to refresh you. The subject of trigonometry that we are talking about here is first class of, when you take trigonometry course that I suppose you have taken, the first class of the course really they go to this elementary, the definition of sine, cosine, tangent, cotangent, and so on. Now, in a right triangle, the ratio of the opposite side to the angle, so the angle that you select is very important. The ratio of the opposite side to the hypotenuse, the ratio of this side to this side, is called sine of this angle. And the ratio of the adjacent side of this angle to this hypotenuse is called cosine of the angle. Now, some students, they kind of say sine squared plus cosine squared equals to 1. That is not true, because I can give a counterexample. When you use a trig function, you must also indicate the argument of that. In other words, the angle should be mentioned. So you see, I'm emphasizing the sine of this angle, the sine of theta. I don't say sine. Sine without the argument is sin, is sin. So try not to commit that, huh? Now, the ratio of this over this is the sine of this angle, and the ratio of this over this is cosine of this angle. Then sine of this angle over cosine of this angle, they both have the same denominator. The numerator of the fraction and the denominator of the denominator of the fraction, they both are same, so they cancel each other. So we are left with sine of theta over cosine of theta, which means we end up with ratio of this over this. Because ratio of this over this and ratio of this over this, the denominators, they start to cancel from numerator and denominator. So the ratio of this over this is going to be the tangent of this angle. If you change the angle, the tangent definitely naturally changes. Now, let me now go to this one. That was just a little aside as a reminder that you may have forgotten some of the elementary stuff in trigonometry. Now, let's see. What I just said is that in trigonometry we call it opposite over adjacent later instead of saying delta y over delta x. Now, opposite over adjacent is same as delta y over delta x. And delta y over delta x was what? y2 minus y1 over x2 minus x1. The 2 points that we select, because 2 point determines a unique line. Huh? Now, we also from the previous lecture, we got that this y2 minus y1 over x2 minus x1, we don't want to repeat it all the time. to represent it with the letter M. So M is this. We don't want to write it all. It's much easier to write M. It's much easier to write 5 than to write 3 plus 2 or 1 plus 4. Huh? So it's much easier to write it M. So we selected the letter M. It's kind of a standard that I have mentioned in the previous lecture. Okay, then we know that the tangent of alpha is same as this side over this side, which is the slope of this line. So tangent of alpha, tangent of this angle is same as M, and I have written here. Okay, now I have put it in writing. I'm not going to go to read it for you because you can always pause and take a note if you wish to do so. But you can also get it from my voice, from my words. I put it for a second, then I take it out, if I may. Okay. Now what else we know? We stand back, stand by. So let's see what benefit now we can take. We know that we are talking about angle and we are also talking about triangle. So how much do we know about these two? One thing we know is that the summation of the interior angles of any triangle in plane geometry, in Euclidean geometry, is equal to 180 degrees. One thing we know. What else do we know? We know that the exterior angle of any triangle is equal to the summation of the two non-adjacent angles to that. I have drawn picture, I will show it to you, don't get scared, I will make it very clear and explicit, and I also tell you what that means by saying exterior angle. So I have the picture, let me go over it for you. First of all, if one of the side of the triangle you extend, I selected this side to extend. You can select any other one to extend. I selected this one to extend, then the angle that is formed from the extension of this side, with the adjacent side, that angle is equal to the summation of two angles that they are not adjacent to them, which means beside this is summation of these two, which means alpha plus gamma is equal to beta. The proof of that is extremely elementary. I wouldn't even say junior high, is a grade school proof. So I'm not going to go through that. So I wrote here beta equals to alpha plus gamma, and this is same as very grade school elementary algebra to say gamma equals to beta minus alpha. Now, if two angles are equal, then naturally their tangents are equal. So we are going to come to that. Now, what I'm going to do is that my point is about the line and the slope and the angle that the line makes with what? With the horizontal axis. I say, okay, if this side of the triangle, I extend it this way and this way, I'm having a line. And if I extend this one, I also have a line, and so on. All right? Now, I'm going to do that and stand back and stand back, contemplate, think and reflect and see what kind of analytical benefit I can get out of it. What kind of information that may provide me. Let's go over that. Now, in this drawing, in this figure, I have extended the sides of my triangle, so I have two lines now. Because this side gives line L2, the extension of this one gives line L1, and that was the originally was there, it was the horizontal axis. Now, beta equals to alpha plus gamma. So that means I do know the angle beta because it's the angle that the L2 makes with the horizontal axis. I know the angle of alpha which is the angle that this line makes with horizontal axis. But from these two I can find gamma. Hooray! Fantastic! Lo and behold, I have already discovered something. What have I discovered? Do you notice that? I noticed that I know the angle gamma, but I don't know the line. The line maybe is in some planet gobbledygook. But the line, I know the angle, so I know the line that he makes. I know the angle, so I know the line, the slope of the line that he will make. That line will make with horizontal axis. So a slope of that line that I haven't drawn is not here. The slope of that line is the tangent of this angle. Isn't that fantastic? What else do we get from this information? We notice that if two lines are intersecting, from this information I can find the angle between them. Meaning from the slope of two lines that they are intersecting, I can find the angle between them. Isn't that fascinating? That's the beauty of mathematics, isn't it? Stand back, stand by, think, contemplate, and see what information you can get. Who was the person the first time who said stand back, stand by? He really has contributed a great deal to the science of mathematics and science in general, huh? Because we are getting all this information from that. Okay, now let's go and discuss this one further. So again, I repeat myself because I'm kind of excited. It's fascinating observation I made. When I know that gamma, from these two angles, I found my angle gamma, and I got two information from that, which means I know the slope of this line, which is the tangent of this angle. I know the slope of this line, which is the tangent of this angle, and from these two slopes, I can find what is the angle gamma, which means I can find the angle that the two lines intersect, and also this angle is what? Is the tangent, is the slope of a line that will be hitting the intersecting with the horizontal axis. That line is not here. Isn't that fascinating? Okay, now will be next one. Well, next one is some very elementary trig formula that you are familiar with. We already know that alpha equals to gamma minus beta minus alpha. We have already seen that. So if two angles are equal, their tangent is equal. Common sense, huh? So the tangent of gamma is the same as tangent of beta minus alpha. But the fascinating thing is that the tangent of beta minus alpha, we have formula for that. Very elementary trigonometry. Sine of A plus B over cosine of A plus B, or sine of A minus B over cosine of A minus B. I'm not going to go through that one. It's again elementary trigonometry. But from that, and a little bit algebraic manipulation after you expand it, a little bit algebraic manipulation using the trigonometric terms, we come up with this formula. So the tangent of gamma is the tangent of beta minus tangent of alpha over 1 plus tangent of beta, tangent of alpha. But previously we saw that tangent of beta, tangent of alpha, tangent of gamma, they were all slopes. They were same. We saw it. So instead of saying tangent of beta, we can say M1 or M2, or doesn't make any difference. Let's say M1 minus M2 over 1 plus M1, M2. Fantastic. So that means from the slope, we can come up and find out what the angle gamma is and what is the slope of the line that will be with that angle, with the horizontal axis. Now, I have put this one in writing, so let me hang it up for you if I may. I'm going up and down, but I hope that it doesn't affect, I hope not. I haven't checked my video. Now here, tangent of gamma equals to this. No, I put the, excuse me, I put the wrong one on. Yeah. I made a mistake. My apologies. Okay. No harm done, huh? What I just said, I put it in writing. Gamma equals to beta minus alpha. Tangent of gamma equals to tangent of beta minus alpha, because these two angles are same. This in the parentheses and this. And then I come to this formula. And then tangent of beta is m2 or m1, doesn't make any difference. m2 minus m1 over 1 plus m1 m2. Now, I come back to see what else. Well, let's see what geometrically, what else I can see before I go to some manipulation of this fraction. Now, this line, L2, I know the slope of that is beta. This line, L1, I know the slope of that is, excuse me, I said the slope is beta. The slope is tangent of beta. This line, L1, the slope of that is tangent of alpha. If I take this line and in your imagination kind of rotate it and bring it here, horizontal, and also the L1, do the same thing, rotate it, bring it up so that L1 superimpose on the L2, then the angle gamma will be 0. There is no angle. They don't make any angle. They fall on the top of each other, superimpose on the top of each other. So then that means that the tangent of gamma will be 0, because gamma is 0. Is that right? And that means what? That means the two lines are parallel. The two lines are parallel. They superimpose on the top of each other. So when the angle gamma is 0, that means the intersection of two lines. If the angle between them is 0, that means the two lines are parallel. Seeing is believing beside. Now, let me go and put this one in. Well, this one I've already said in words, but let me just hang it up with you for the case. Tangent of gamma equals to this, and this is m1, this is m2, 1 plus m1, m2. Now we are going to discuss about this fraction and see what kind of information that can give us as far as the tangent of gamma is concerned and the angle gamma is concerned. Now, do I have it? Yes, I do. So remember what I just said, huh? So now if the gamma is 0, what does that mean? Means tangent of gamma is 0. Is that right? So if tangent of gamma is 0, tangent of gamma was equal to this. You remember that? Tangent of gamma, tangent of gamma is equal to m1 minus m2 over 1 plus m1 m2. So tangent of gamma equals to this fraction. So when we say gamma is 0, we are saying this fraction is 0. Now, when is this fraction is 0? For under what condition this fraction is 0? This fraction is 0 if the numerator is 0 and the denominator is not 0. Now, when is the numerator 0 of this fraction? The numerator is 0 if m1 and m2 are same. They have same value. m1 minus m2 will be 0. But then, again, stand back, stand by, don't rush. Take your time and say, hey, you said that numerator is 0. How do I know there are values for m1, m2, m2 that the denominator will also be 0? What happens in that case? I know you said if the numerator is 0, then what? The gamma is 0, the tangent of the gamma is 0. How do I know denominator is not also 0? Under what condition? Well, that is a good question. And let's stand back, stand by, and see what we can give answer to this. Okay? Now, if m1 and m2, they both are positive, then the product of them is positive. Is that right? And positive plus 1 is more positive. So we have no fear denominator to be 0 if m1 and m2 are both positive. Number 1. Suppose both are negative. If both are negative, then what happens? Then negative times negative is positive. Again, positive and 1 will make what? Will be more positive, so again denominator is not 0. Now, what happens if m1 and m2 are 0? What happens in that case? If m1 and m2 are 0, then the denominator is 0. Don't forget, this whole fraction equal to 0, so we cannot say m1 is different than m2. So, if m1 and m2 both are 0, this product will be 0, but the 1 doesn't let the denominator to become 0. Fantastic, huh? So from this observation, we come out of the fear of 0 over 0 case. So if this fraction is equal to 0, we have guaranteed that the numerator is 0, denominator is not. And if the numerator is 0, means the two lines are parallel because they have same slope. m1 minus m2 equal to 0 implies m1 equals to m2. Isn't that fascinating? Okay, now this one I have already discussed. I don't think I need to put it up. And then this one I have just what I just said. I put it in writing because those students that they may be taking notes. They like to take notes, they can maybe a little bit I pause. So what I just said, I said you have no fear of denominator to be 0, which means you have no fear of 0 over 0 because I explained that and I put it in writing for you. Now, then the question comes, let me see, yeah, let me use this one. I was going to use the previous one. Let me use this one now. Now, don't forget what we are doing. We are looking at this fraction, m1 minus m2 over 1 plus m1 m2. We are looking at that and see what kind of information we can get out of it. We notice that we have no fear of 0 over 0. And we notice that if this is equal to 0, then numerator will be 0. And if numerator equals 0, means that the two lines are with the m1 and m2 slope, they are parallel. Okay, now what happens if the denominator is 0? Again, I repeat myself, if the denominator is 0, that does not imply that numerator can also be 0. So under what condition denominator is 0? Well, very elementary algebra, if you don't see it, just set it equal to 0. If the m1 times m2 is equal to negative 1, that means if the product of two slope is negative 1, then the denominator of this fraction is 0. But what is this fraction? What is the whole this fraction? The whole this fraction is the tangent of gamma, you remember? Therefore, if the denominator is 0, the tangent of gamma is not defined. Some people, they like to use it infinity. You can either use it infinity or you say it's not defined. So if the m1 times m2 equals to negative 1, then the denominator becomes 0. That means the tangent of gamma is not defined. Means the two lines that they have intersected, they are perpendicular to one another. Because the tangent of what? The tangent when this one is undefined means that the gamma should be 90 degree, because the tangent of 90 degree is, you can say, either infinity or not defined. So let me go again one more time slowly. If the numerator is 0, if this fraction equal to 0, the numerator is responsible. So we know the two lines are parallel. And if this fraction is not defined, is infinite, the denominator of that at 0, that means the gamma should be 90 degree. Means the two lines have intersected with perpendicular to one another. And I have written, yes, tangent of gamma not defined or infinity, that means the two lines L1 and L2 are what? Are perpendicular to one another. Okay, now let me see what else I have. Now I have put this one in short writing if you want to write it. I'm not going to read it for you. I pause for a few seconds because you can stop you can pause in your computer and kind of maybe zoom it and write it in case I think it's visible and readable. Okay then, I pause a few minutes. I already talked about that. I said few minutes, few seconds, and now I go to the conclusion. And the conclusion also is a kind of, I don't have to mention it. I can just leave it for you to write, but I go over it anyhow. Okay. Look what I have said. Let M1 to be a slope of a line L1. And M2 to be a slope of a line L2. Alright? Then this fraction M1 minus M2 over 1 plus M1 M2 can tell us about the status of L1 and L2 with respect to one another. So this fraction can tell us what kind of a status the two lines L1 and L2 they have with respect to one another. Meaning, are they parallel to each other? Or are they intersecting? And if they intersect, are they perpendicular to one another in intersection, or they intersect that they are not perpendicular? This fraction tells us all about this, the status of the two lines in a coordinate system, in a coordinate geometry. So I have written for you, huh? You can pause it and write it. Okay then. I would like to thank you for watching. I hope that this video was beneficial to you, and I'm planning, my time permits, to make a kind of video lecture, maybe it will be a kind of long, about absolute value, because from my experience many students have difficulty with that. I do not know why, but I'm going to dive inside, screw diving, and take a lots of information up that will be sufficient for basic algebra, college algebra, pre-calculus, and also calculus, because all these students, they have difficulty with absolute value. Okay then, until then, I wish you all prosperity and good health and happiness, and please stay safe. And thank you for watching. So long.